Thank you very much. And so I'm Buff Furman from Mechanical Engineering, along with Mojtaba Sharifi. We're co-teaching a course, ME EE 106, Fundamentals of Mechatronics, and we'd like to share with you a bit of our journey in the area of specs and mastery. So I'll continue. So what we'd like to do in the presentation today is cover just a little bit about what mechatronics is, how it was structured pre-work on specs and mastery, and how the course has been modified to kind of synthesize specs and mastery, and what results we have so far and what we're planning to do for the future. So let me explain a little about what this course is. So it's a required course in the BSME program at San Jose State. It's given every semester, tends to have more in the spring than in the fall, but those are approximately the numbers. It's mostly third year students or fourth year taken by seniors. And it's a mix of lecture and lab. So 2 50-minute lectures a week, 165-minute lab. And the way the lab is structured, 9 kind of experiments that they do to learn the various aspects of mechatronics. Students work on those in teams, but they have to write individual lab reports for the 9 structured experiments. And the course also has an open-ended term project where teams of like 2 to 4 work to design a solution, mechatronic solution to an open-ended problem using sensors and actuators controlled by a microcontroller. So prior to spring 21, it's before actually we took the TEA workshop, the grading of ME 106 was points-based. So it consisted of homework, lab reports, project, a midterm, quizzes, final exam, and individual performance to keep people accountable on the term project. So in spring 21, there's a lot of backstory on this, but I introduced a mastery framework, or at least a very initial attempt at that, to kind of move away from just assigning points for a grade to really being able to demonstrate mastery of concepts in the course. And it was greatly influenced by Scott Ellis from Mastery Track in this effort to help me think through what it is mastery is all about. And it comes down to really defining learning objectives very clearly about what students need to know and be able to do. And then just defining mastery thresholds for each of the learning objectives so that it's clear to both instructor and student what mastery looks like and how we know that a student has actually achieved or mastered a learning objective. And then providing some kind of scalable processes for the students to demonstrate the mastery of the learning objectives, as well as some way for the instructor to actually know how students are doing in that. So that's kind of the core elements of where I started with mastery. And as we started into this, the midterm was replaced with mastery quizzes in Canvas. So instead of a sort of high stakes, go take this midterm and assign partial credit, what have you, it was a set of quizzes where students would have to demonstrate like 80% or better to have achieved the mastery of that learning objective. So the learning objectives that we have are here. I won't go through all of these, but they're articulated as to what they are. And we allow the students to retake mastery assessments until they're passed. And I'll show you what the grading scheme and how this goes here in a couple slides. So just to kind of look at what the outcome was of this change in spring 21, I put a survey out, my own survey, as to what students thought of this mastery approach compared to a regular course. And this is kind of the outcome, which was very positive. And I like the quote from the student as to, it was typical of some of the feedback as to mastery and why they liked it. better than the regular approach to learning. So that being encouraging, and when I saw the announcement for the TEA workshop last summer, which also mentioned mastery in its kind of advertisement, I thought this would be something really good to do. So as a result of that, we changed how we were grading the lab reports from a sort of point-based, which I'll show you in a second, to a specifications grade for the lab reports, but synthesized also with a quality score. Another thing that we did in fall 21 was to refine the grading scheme to make sure that all assignments were completed. So heretofore, students, some would maybe miss a homework assignment here or there, or maybe not turn in a lab report. And it ends up providing a lot of holes in their understanding if we were to allow that. So in order to pass the class, everyone has to turn in all of the assignments. So here's how the lab reports used to be before we did specs. So this was kind of how grades were given for the lab reports. As you can see, basically on points for the various sections of a lab report. So after the workshop last summer, we basically took each one of those elements of how a lab report was graded and turned them into a specification. So here's for, say, the summary. It either meets or they have to revise the report if, say, the summary was not succinct or completely described what was done, and things like that. So we went through and developed these specs for all the aspects of the lab report. But I'll show you the last piece here, which is a little bit of a synthesis, maybe not exactly the specs kind of approach, but an overall quality grade for the report. So if it was, quite well written, attention to detail, all of that, they got a score of 5. If it was, pretty good, 4. And if it was okay, yeah, you met all the specifications, it's a 3. So it was just a way to kind of be able to spread out, in a sense, the overall quality of attaining these learning the objectives for the lab reports. So I'll turn. This is my last slide, and then I'll turn it over to Professor Sharifi. But this is how it figures into the overall grading for the course. So as you can see through here, we've got the attainment of learning objectives as a 20% for their grade, lab reports 15, homework 10, term project, individual performance, and a final exam. And so depending on how well they do on these components, they will basically get an overall weighted kind of an average, which will actually determine a grade. So we differ a little bit in how we implement the specifications and mastery from a pure specs approach, where things are put in grade bundles, and if you achieve more in some bundle, you get a higher grade. So this is a little bit different, but seems to be working for what we're doing. Okay, so I'm going to turn it over to Professor Sharifi to talk about how things went from the survey on specs grading last semester.
Thank you. Hello, everyone. I am Mojtaba Sharifi, a new assistant professor at Mechanical Engineering Department. And we had this course together with Dr. Furman this semester. But I'm going to talk about the result that we got from a study that we have, and 17 students participated in that study for the semester fall 2021. So we asked the students a couple of questions, and I'm going to discuss the results of those responses. So I'm basically talking about the first and second column mostly in these slides. So regarding their academic performance, out of 17, 12 plus 3, which is 15 students, believe that they could have enhancement in their performance. Next slide.
Sorry, that's me.
Yeah, sorry about that. And regarding their engagement in the class, again, majority of them, 8 plus 4, which is 12 students, believe that they could have more engagement in the class. About their confidence in the class, again, 7 plus 5, 12 students mentioned that they could get more confidence to participate in the class assignments. And this is an important piece of information about understanding. So you can see 8 plus 7, 15 students, which is around 90% of students, believe that they could have more understanding about the course material and the subject using specs grading system. And about their curiosity to learn the subject, we can say around 50% mentioned that they could have some improvements and they could be more passionate about the subject that they are learning using specs grading. And about their intelligence, so they could benefit more from the intelligence. So 9 plus 5, 14 students, majority of the students thought that they could benefit more from their intelligence using this system. About setting goals and achieve them, 50% of the students believe that they could basically set the goals better than the previous point-based system. And about enjoying the challenge of assignments, again, a couple of students, 5 plus 3, 8 students thought that they could enjoy challenging assignments. Others said that they were neutral, like between specs grading and point-based grading. And about the ability to take the risk while learning, 6 plus 4, around 50%, more than 50% of them believe that they could take more risk because we give them more chances, for example, to do mastery quizzes, and that makes sense that they can take more risk while learning. And this is another piece of information that is important, and that's about learning from their mistakes. So 8 plus 6, 14 students believe that they can learn from their mistakes. Again, that's the result of giving them a couple of chances for the quizzes, and also for lab reports, we are giving them some feedbacks so they can learn better from their mistake. And then this is kind of similar. Basically, they could improve their learning. So again, 14 students believe that they could improve their learning. Regarding overcoming challenges while achieving their goals, again, 12 students out of 17 believe that they could overcome the challenges better using this system. And ability to solve engineering problems, again, 8 plus 5, 13 students mentioned that they could solve engineering problems better and easier as a result of that system. About design engineering artifacts, that was a question there. So less than, I would say, around 50% believe that they could have those design artifacts better. About the level of stress in the course, again, 50% believe that they could have less stress. That's something that I expected before starting this system, and as I talked with Dr. Furman. But it seems that we still need to work on that to decrease the stress of students using this system. And about growth mindset, this is another important point, that most of the students believe that they could have a growth mindset, as we said, because they can learn from their mistakes and they can have, a couple of trials to do the quizzes or for lab report. So with that, I'm giving back to Dr. Furman about the results that I explained.
Okay, thank you very much, Professor Sharifi. So just to kind of summarize again what we saw with mastery and the sort of specs from the specs survey, it's encouraging. The mastery approach, and I've seen it in another course that I've taught, at least from the student's perspective of what they think they're learning and how they're learning it, seems to be better. And at least from this survey of a relatively small number, we'll hopefully get some more data at the end of this semester, that the biggest gains seem to be the students emphasizing their understanding of the subject matter, intelligence. I'm not exactly sure what that means, but that was the question that was asked, and we didn't make them up. So, and ability to learn from my mistakes was also one that most people felt that the sort of specs mastery approach helped them with, which seems to be going along with what it does from the outset. Improving learning and developing a growth mindset. So I think by and large, we're encouraged by that. We also tried to use the token economy that we learned about last summer to allow students to either redo or turn in late work. And we kind of ran into some problems with that. And it may have been operator error or professor error in implementing them. But it tended, from the feedback we had from our TAs for the lab was that the email-based approach overwhelmed them to handle the requests. And so they felt that it would be better to set fixed deadlines and then allow rework to be done on a sort of per person basis. So it seems to be working a little better this semester, but we need to debrief and see if we need to make some changes for next semester. So Professor Sharifi, go ahead on this one.
Sure. Like for the next semester that I will teach the same course, ME 106, I had discussions with Dr. Furman how we can improve this system more. And we believe that we can have some improvement for learning objective, basically mastery quizzes. And because basically the students, when they don't pass the quiz, they have like 1 or 2 chances to take that quiz again, but the questions are kind of the same. So we are thinking to give them different questions to make sure that they are learning instead of just copying and pasting the solution or just memorizing the solution. So that's one change that we want to have for the next semester. For the lab reports, we saw that most of the students ask about one choice to rewrite the lab report. So we are thinking to give them 1 or 2 tokens to do that, to redo that. That would help them, because if we give them this feedback, for example, in the first lab reports, they would learn that and they can apply it for the next lab reports. So it's good to have it at the beginning of the semester. So about the term project, because this course is kind of complicated with theoretical material, labs, and also project. So at the end, they have to make a lot of effort for term project, and that would increase their stress, as we are seeing that right now. So I'm thinking for the next semester, we can basically give them some information and shape their groups from the beginning and start the term project from the beginning of the semester. So that would increase their learning possibly. And can you go to the next slide? Yeah, so that was 3 improvements that we are thinking of them right now. And hopefully we can implement it next semester and see what is the feedback, what is our result of applying these changes. So with that, we finish our presentation and we are open to your questions.